Hello and welcome to fifth lecture of fifth chapter of our comprehensive course on machine learning, data science and artificial intelligence. Now, in previous lecture we had seen that NumPy arrays can very efficiently do element-wise operations, but for them, the example which we took had two arrays which were of same dimension. And I said that what to do if arrays are not of same dimension. For example, this is an array which is a 3 by 4 array, and this is an array which is 3 by 1 array. Okay, so the question is, can we do element wise operations on these? Or for example, someone has asked me that add these two, then yes, NumPy can handle this. There are conditions for that. What are those conditions? I will tell you, but the condition is that any one dimension between the two arrays must be equal. So here these has 3 rows and these has 3 rows, condition is satisfied. Or another condition is that even if both dimensions of the two arrays, none of them are equal, rows are also not equal between the two arrays, columns are also not equal between the two arrays, then at least one of the arrays should be a one-dimensional array. So here even that condition is satisfied. So in short, you can say that broadcasting will occur. Now what is this broadcasting? Okay, so if you have your WhatsApp group and you have enrolled all of your friends, or maybe you are a educator and you have enrolled all your learners in your WhatsApp group, okay, and you are you want to send the same message to each of them. So that is the purpose of making the group. Okay, say instead of storing each contact individually, what you do, you and then sending the message to each one by one by copy pasting or by forwarding, send the message to first person, then forward to second person, then forward to third person. No, we put all of them in one pool, one group, and then send a single message to our group that we often call broadcasting of the message. So somewhat similar is thing is happening in array broadcasting. For example, when I am adding these two, actually what happens is something like this. That means that this 5, 6, 7 that does not have column number 2, column number 3 and column number 4. So how would I add corresponding elements? Because corresponding word is applicable only for column 1, but here this has column 2, this does not have column 2. And broadcasting principle says simple. If it does not have column 2, that replicate column 1, it becomes column 2. Again replicate it, so it becomes column 3. And again replicate it, so it becomes column 4. So somewhat like this, okay? And of course, these gaps should not be there, but actually everything is in 1. So then thereafter it is just, this is also a 4 by 4 array, and this is also a 3 by 4 array, and this is also 3 by 4 array. So do ordinary 0 plus 5, 5, 4 plus 6, 10, and 8 plus 7, 15. So that would be my first column. Then 1 plus 5, then 6, 5 plus 6, then 11, and 9 plus 7, then 16. That would be the second column, and so on. Okay. So that is one thing which I can do. But the question is, first let us create these two arrays. So how to create these two arrays? Then this array can be created by np.arange and 12. Okay, 12 means starting point is not mentioned, so default value 0. Ending point is 12 means up to 12 but not including 12. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so that is these elements that you can see. Fine. And step size is not mentioned, so the default step size is actually 1. If I do not write this reshape here, both, then I will get a 1D array. But that is how actually one should learn initially. That whatever array you want, first you create all that. Just see what elements are needed and create a 1D array of that. Okay, so this is that 1D array, and I at least have now 0 to 11 elements. Now then, once they are created, then just reshape it to required dimension. So here I need 3 rows and 4 columns, so I put a reshape, and then this is now required left side pink array. And similarly here I need only 5, 6, 7. I'm talking about this single array. So if I write it this way, I will get 5, 6, 7. But I need it 3 rows and 1 column. So then what I would do? Reshape 3 rows, 1 column, 3 rows, 1 column, and press Control Enter, and I'm getting this. Now if I add these two, then what is internally happening is what I have shown here, that this 5, 6, 7 is replicated 3 more times, and thereafter the corresponding elements are added. So if I see them, then you can see that this 0 plus 5, then 5, and all that corresponding elements would be added. 1 plus 5, 6, 5 plus 6, 11. Check any element, and the element-wise addition is possible. Okay, so now we are clear what is broadcasting. Broadcasting is a set of rules by which NumPy can perform element-wise operations on arrays of different sizes. The smaller array is broadcasted, that is repeated multiple times, just like same message is broadcasted multiple times in the WhatsApp group. Okay, somewhat similar, broadcasted across the larger array so that they have compatible shapes. So that means this 5, 6, 7 is broadcasted 3 more times, so that now compatible shapes, 3 rows, 4 columns, pink, and 3 rows, 4 columns, gray also. So then thereafter it is just like ordinary vectorized operation, so that you can do element-wise operation. And broadcasting can, one more example we are taking of broadcasting. This example I am taking because I want to introduce this function. So far we have done something like np dot zeros that will create all an array of all zeros. Np dot ones that will create an array of all ones. Then np dot full, and in bracket I can write how many elements and which element. Okay, so that will create, say 7 I write, then it will create an array of all all number 7. But suppose someone says you that create an array which is having some totally random integers. So at that time np has this one function, np dot random, just like np dot zeros, np dot ones, np dot full, like that. This is np dot random, and then after that you can write rand int. So randomly selected numbers, that is what this means, and those numbers must be integers, that is what this means. And how many they should be? They should be not how many, this 5 decides the limitation, and this size should be 3 rows and 4 columns. Okay, let me put first this b, or okay, I am printing only a, so fine. So you can see that this 5 decides the limit. Okay, say all integers randomly selected, but up to 5 but not including 5. So that is 0, 1, 2, 3 and 4. Repetition is allowed but randomly. Next time if I execute, I will not get the same output. Note down this output 1, 2, 3, 1, 4, 4, 2, 4, 0, 3, 0, 3. If I next time indicate, you can see that random itself means next time it will put some different random numbers. It will just maintain these two conditions, that all numbers must be less than 5, 0, 1, 2, 3 and 4, and it will be of this dimension, 3 rows and 4 columns. Still next time if I do, some still different numbers. So this is a very useful function, because many times we need to create random numbers in many programming and data science applications. So at that time, particularly when you are creating synthetic data, so at that time random int and etc. functions are required. Okay, fine. Now here we are creating one another array, which is not even array but just a number 2. Okay, and let me just print that, print b. Okay, and now create this. Now if I add these two, a plus b, then how will the addition occur? This is one scalar. This is not even a vector. This is a scalar. Scalar means something which is not vector, say, or that is an ordinary number. It has only magnitude. So then this is a scalar, and then one scalar and one vector can also be done, can be used in element-wise operations, and there also broadcasting occurs. Okay, so addition of a scalar with an array, and addition of two arrays of different size. So this is first part we are doing, addition of a scalar with an array. Okay, so here what will happen? This is already, its size is fixed. It is a 3 by 4 array. Then these two will be repeated, broadcasted along the row axis also, so that there are column axis also horizontally, so that there are 4 columns, 2, 2, 2, 2, and it will be broadcasted vertically along the row axis also, so that there are 3 rows. So 2 and another 2 below it. So ultimately it will become first this kind of array internally, like this, and then this and this will be added. So let us see what will happen. 2 plus 2, 4. 3 plus 2, 5, and this 3 plus 2, that is also 5. So at least first column should be 4, 5 and 5. Similarly other columns also you can check. Just one I am checking, 2 plus 2, 4. Okay, so that is these 4. Or maybe here 1 plus 2, so 3. So then this is 3. So this is broadcasting of one scalar and one vector. Okay, or matrix actually. So what are the rules for such broadcasting? That I have already spoken earlier, that either there should be one dimension which is equal. Either the number of rows in 2 must be equal, or the number of columns in 2 must be equal. So that means if one is 3, 1 and another is 3, 1, fine. One is 3, 1 and another is 5, 1, that is also fine, because at least number of columns are equal. And if even that condition is not satisfied, then the condition is that if suppose one is 3, 4 and the other dimension should be, at least one dimension should be 1. So that is 1, 5, say. So 3 and 4, these have 3, 4 dimensions, first array, and the next array say, has 1 and 5. So then broadcasting can occur, and automatically this kind of operation or this kind of operation internally will occur, and then addition will occur. So hopefully broadcasting is very clear. Now here it is given that consider this example. Okay, so we have two dimensional arrays. So this is one array, 0, 3, 1, 3, 1, 0, 3, 4, 3, and this is another 2D array, 1, 4, 2, 4, 2, 1, 4, 5, 4. Okay, and size are equal. Both are 3 columns and 3 rows. Okay, this and this. However, one of them has size 3 in the first dimension and the other has size 1. Sorry, so I think that we are not talking about this. We are talking about these and this. Okay, so this 3 by 3 and 3 columns, and this is also 3 columns, but it has only 1 row. Now in this case, what will happen if I try to add these two? Then obviously, first, if dimensions are, say, the common thing about broadcasting is just to remember that if the two arrays are not equal, make them equal. So that means repeat, broadcast, this is 1, 1, 1. So that make it 1, 1, 1, below it again repeat 1, 1, 1, and below it again repeat 1, 1, 1. So that now it is easy, 0 plus 1. So that is 1. 3 plus 1, so that is 4, and 3 plus 1, that is also 4. So this is the resultant array, okay, and that is first. Then 3 plus 1, 4 here, 1 plus 1, so that is 2, and 4 plus 1, that is 5, okay. Now it is possible that two arrays have different size in both dimensions. Say first array has a shape 4 1, so now it is only a column, something like that, so 4 rows and 1 column, and second array it has 1 4, so that is having 1 row and 4 column, but it satisfies that condition that okay, that there are two conditions for broadcasting. One, size in any one dimensions must be equal, but here unfortunately they are not equal. This has 4 rows, this has one row, this has 1 column, then this has 4 column, so the size in both dimensions are different. But then other condition is also there, at least, or if that condition first is not satisfied, then at least one of the dimensions should be 1. So here you can see that condition is satisfied, one of the dimension is 1. So then what will happen? Both will be broadcasted, okay, and at that time how they will be broadcasted, that is important, okay. So they will be broadcasted in such a manner that both will have number of rows equal to the maximum number of rows out of two original arrays, and number of columns was also equal to the maximum number of columns out of two original arrays. So what will happen? This has 4 rows, this has only 1 row. So that means when broadcasting occurs, maximum number of rows will be selected, so 4 rows will be selected. So I now know that my broadcasted array should have 4 rows. Okay. Now this has 1 column only, but this has 4 columns. So again, when broadcasting occurs, maximum number of columns will be selected. So 4 columns will be selected. So ultimately what will happen? These will be broadcasted 1 2 0 3, then next 1 2 0 3, then next 1 2 3 0 3, and next 1 2 0 3, something like this. So that it is 4 rows and 4 columns. Similarly, these will be broadcasted 4 3 3 3, below is another 4 3 3 3, below is another 4 3 3 3, and another 4 3 3 3. So that also is 4 rows and 4 columns, and thereafter the addition will occur. So if you add them, 1 plus 4 5, it is here, 2 plus 4 6, it is here, 0 plus 4 4, it is here, or I choose some random, say this is the corner, 3 plus 3, so 6, so it is here, 3 plus 4 7, so it is here. I'm not showing all, okay. Now suppose we want to create these two arrays, then what will be the method of creating these two arrays? Initial chapters are there, so I'm actually typing the code and everything, but as I said that if you do this at this speed, then it would be very difficult to cover everything that we want to do. But let us actually, initial chapters are there, so let us create. So first array, a equals np.array, inside a list is there, and first take all the elements 0, 3, 1, 3, 1, 0, 3, 4, 3. Okay, but remember that is not my required this left side array at present. Just I have selected all the elements. If I print that A, it will be something like a simple list, like simple. But thereafter, once all elements at least are included, just reshape. So reshape, and I need 3 by 3. Okay, so 3 by 3, fine. And thereafter, if you print, then you will see that it will be like that left side array. Are you getting it? Fine. Now, similarly, the other one, that is B. So B is a array like this. Okay, np.array and double square bracket. So that is, it is already 2D array. Though we are having only 3 elements in the beginning, that is another matter. But if I at present write this way, then it would not become 2D array, but then I immediately have to reshape. And which way you want to reshape? I want to make that also 3 by 3. So 3 by 3. Okay, and then what is the problem? Cannot reshape an array of size 1 into. Yes, the mistake was that I want to create a 3 by 3 array, then I must have 9 elements, no? So that means 1 1 1, then another 1 1 1, then another 1 1 1, and then reshape 3 by 3. Okay, and put a B so that I get that kind of. So when you do addition of these two, this plus this, then you get this kind of, first this is converted into this kind of array. Okay, and then addition of corresponding elements will occur. But here I did it by adding 9 elements myself. What I want to show is that broadcasting takes care of that automatically. Okay, so what I'm saying is that let us take only 3 elements, let us not reshape, but our array we take 2D array. Okay, so first array is fine because it is given as a 2D array, so we have to reshape and create a 2D array A. But the right side array, so I'm creating at present, it is this kind of array. Now you can see that. But now if I do A plus B, then also I get the same result. So internally what has happened is this has become, A1 has become broadcasted along the other dimension. Then internally this has reshaped into 3 by 3 array, and then sum has occurred. Okay, so I hope that the broadcasting is clear in your mind. Okay, let me remove that, and I want to keep original thing only, because then also you get the same result. That is important thing. Okay, so for broadcasting, you don't have to manually count that 3 by 3 means I need 10, 9 ones and everything. Okay, now these two arrays, also I can do the same thing here. Okay, let me add a few cells. As I said, this is actually a little bit of headache in the sense that counting, but okay, fine. Initial stages are there. So 1, 2, 0, and 3. Okay, and this is a 2 by 2 array. I mean 2D array, not 2 by 2, but 2D array. So two square brackets are there. And similarly, B equals np dot a range. Again, it is a 2D array. 4, 3, 3, 3. But for the first one, I will have B is fine because it needs to be along a row. But for A, I need them along a column. So I will have to reshape. How I will reshape? I need 4 rows and 1 column. Okay, fine. So that is also a 2D array. First, let us print A, let us print B, and let us check if our A and B as shown above are obtained or not. Okay, so they are A range, not range. Why I am writing range? NP dot array. I don't know what has happened. Okay, and NP dot array. Fine. So A and B, and then I want to add them. So internally, this thing will automatically happen. I don't need to broadcast myself by code. Okay. So this before adding, as I said, this has 4 rows. So then this will also get 4 rows. How it will get 4 rows? Then its first row will be replicated 3 more times. Similarly, this has 4 columns, but this only has 1 column, so it must also get 4 columns. How it will get 4 columns? Its first column will be replicated 3 more times. So then, when you do the addition of A plus B and print them, then you will see that you get this kind of array. Okay, so internally A has been broadcasted, B also has been broadcasted, and A plus B is coming out to be this kind of array. So it has maximum of the 2 original that many rows and maximum of the 2 original that many columns. So 4 rows and 4 columns. Okay, so 4 by 4 array. Fine. So I hope that broadcasting is clear. We have done it 2 times in previous chapter and this chapter, because when this happens like this, no such picture is given, then sometimes it feels like what has happened. So you should remember this, and please remember that for broadcasting the condition is that any one dimension must be equal. Either both must have equal number of rows or both must have equal number of columns. And even that is not satisfied, then okay, fine, but then at least both must have one dimension, rows or columns, equal to 1. Okay, so 3, 1, 5, 1, like that. Okay, thank you.